In this video, we're going to be going over what position, velocity, and acceleration are. Three very big deal ideas in terms of calculus and physics. Some could argue that it's the reason why calculus came about. So anyway, let's dive into it. We've got that position is where an object is at a specific time. So in calculus, you'll often hear the word particle moving along, an x-axis or a y-axis. So here we've got an x-axis, and we're going to have a particle moving along that. So let's say that we've got a position of 0. That could be 0 feet, 0 meters, whatever it is. And let's say that you've got a particle at position, I don't know, let's call that position 5. It could be 5 meters to the right, or it could be 5 meters to the left. So if I put a particle here, like a dot, then that particle is now 5 meters to the right of 0. Its position is 5. You could put it all the way over here at 10. Its position would then be at 10. So I always joke around with my students, position is kind of like answering the question, where are you at? Right? So where are you at a certain time? That's what position answers. What then is velocity? Velocity is the direction and speed with which an object is traveling. What does that mean? Well, here's another way of putting it. It's the rate at which position changes as time changes. Okay, so before we get into the notation of everything, and I'll get back to the notation of position, rate of change is another way of saying this, either instantaneous rate of change or average rate of change. And so let's say that you've got a particle moving from 0 to 5. And over the span of 2 hours, it moves from mile marker 0 to mile marker 5. So you've gone 5 miles per 2 hours. That would be the average velocity, right? It's the rate or the displacement divided by the time. Had we moved to the left 5, that would be -5 over 2. So we've gone left 5 per 2 hours, or 5 miles per hour, but to the left or going backwards, depending on what the context is. So let me erase that stuff right there. So that's the idea of velocity, is how fast are you traveling. Put simply, if you're in a car and you look at the speedometer and you're going, I don't know, 30 miles per hour, or let's say you're going 100 kilometers per hour, those are velocities. So it's speed with direction. If you have a negative value, you're going backwards or in the opposite of the positive direction. Here to the right is positive. So if I have a positive velocity, I'm moving to the right, and a negative velocity, I'm moving to the left. Those are the important pieces of that. As for the notation, you'll often see notation like S parentheses t, or S of t for the position. Sometimes it's X of t or Y of t, and that's the position. S prime of t is the derivative of position. That is velocity, instantaneous velocity, which makes sense. If you find the slope at an instant on the position curve, you're basically saying, how are we changing, right, in terms of where you are per time, miles per hour. So that's why velocity is the derivative of position. Average velocity is delta S over delta T, or the change in the position over the change in time. The difference between these two things is very subtle, yet huge. Maybe it's not so subtle. So if I draw a random curve, let's say this is a curve that describes the position at any time t. The instantaneous velocity at a time would be this right here. It would be the slope of the tangent line at a point, the derivative. That's how fast you're going right now, like you're clocking a car with a radar. Change in position over change in time, that average velocity, that's the slope of a secant line. So that's saying I started at this mile marker, I drove for a certain amount of time, don't know how fast I was going at any one time in between, but I ended at a certain position. What's my overall change in position divided by change in time, my overall average velocity? And I illustrated that actually before here when I talked about it earlier in the video with going to the right 5 over 2 hours. Rather than saying, stop, how fast are you going right now? That would be the derivative. There you have it. Okay, then finally, acceleration. What is acceleration? Acceleration is the rate at which velocity changes as time changes. I should say as time changes, not at time changes. So what does that mean? Well, It's essentially like the relationship between position and velocity, except we're going down another level. I like to think of it as levels: position to velocity, velocity to acceleration. So you're saying, what is the rate at which velocity is changing as time changes? So the notation is very simple. To get instantaneous acceleration, how fast velocity is changing and in what direction is it changing at a set time, you'd either take the derivative of velocity, which gives you a of t, acceleration at a time, or you take two derivatives of position. Since the first derivative of position is velocity, and the derivative of velocity is acceleration, that's like taking two derivatives of the position to get acceleration. That's instantaneous acceleration. Average acceleration is the change in velocity over the change in time, just like average velocity works that way. Acceleration is if you look at the speedometer and you say, well, how fast is that needle changing as time goes by? So that would be, all right, my miles per hours are changing per hour. So those units are like miles per hour per hour. We'll see units down the road there. But let's say that we've got an acceleration curve, sorry, a velocity curve. And let's say that the velocity looks something like this. So the instantaneous acceleration would be the slope at a point. Boom. So it would be the slope of the tangent line at a time. The average acceleration, remember this is your velocity curve, the average acceleration would be the slope of the secant line. So that would be like saying we went from 30 miles per hour to 60 miles per hour over the span of 1 minute. What is the acceleration? It would be that change of 30 miles per hour per minute, right? So that's the slope of the velocity graph. And that's it. You've got your notation, you've got your relationship between position, velocity, and acceleration. We're going to go rock some problems now that we've got this knowledge. I'll see you in the next video.